Okay, this video is on exponential functions. It's our intro lesson that we went through to introduce what an exponential function is. So we started out with these four graphs, and we said, name three things you see about them. And a lot of kids talked about how they had an x and y axis. There was this curved line. We're used to seeing these straight lines, right? We've seen things that look like this. And so it is now curved. And that was the biggest topic that we had. And so when looking at it, we also looked like the slope at the beginning of it is very small compared to the slopes later on in the graph. Like the slope of this green versus this orange. The orange is by far steeper, so it increases a lot faster as time goes on in this particular instance. As you move to the right, it's increasing faster. And that's what an exponential function looks like, the graph of it. And today what we're going to do is take data from a table and write it in an exponential function form, which we'll talk about here in a second. The main thing with this is it's very contextual. So for instance, some of you have heard before, like, hey, I'm going to put $1,000 in a bank account and I'm going to get 5% interest on that at the end of the year, which is going to result in you getting $1,050 at the end of the year. And so when we do that, and if we wanted to find that out after a series of 60 years, we're going to be here a long time, because now what we're doing is we're taking 5% off of the last amount. So it's not going to be just adding $50 each time. We can't just say, well, we're going to add $50 every year, because that's going to grow little by little. And at the end of this year, we're actually going to have $1,102. So if we wanted to figure out what this is at the end of 60 years, it's going to be a lot easier if we can come up with an equation where we can plug it in either with our calculator, or we can do the math by hand to find that out much, much quicker. So that's kind of where we're at. That's the goal where we're going. And so we're going to look at tables today and create the equation. So exponential functions, this is just kind of the words of it, right? So to compare the two, we had linear functions in the past, and that's where we added. The y values were added by a constant value. Exponential is different because we're going to multiply the y values, and that's way easier to show you than to say it. When I say it, it seems kind of confusing, but we can see it right here on this slide. Are these tables linear or are they exponential? And we'll look at this first one, where we did this in the first semester, where we see that we're adding 1 each time on the top. So our x is just changing by +1. The y is changing by +3. We're adding 3 each time. That's what we mean when we say that we are adding. The y values are added by a constant value, because we're adding 3 each time. So this one right here would be linear because we're adding. Down here on these next two, in fact, they're going to be exponential, and I'll show you why here. Because we're still adding 1, right? +1 on the top. But on the bottom, you're going to notice that we're multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So we are here multiplying the y values. So when the y values are multiplied by a constant value, and that's the distinguishing factor. So if you are ever given two tables, what you want to do is see, are we adding each time, or is there a multiplier? And if there's a multiplier, then that means we're going to have an exponential graph, or it's an exponential table. You're going to see the same thing here. This one's also exponential because we are multiplying by 3 each time. Okay? And then in class, we had an opportunity where kids could do this on their own. A lot of the kids would notice that we're subtracting 2 in the y value each time. So this is going to be linear, right? You can view that as you're subtracting 2, or you can view it as you're adding a -2 each time. Either way, we're technically still adding. And then this one is unique because a lot of kids notice that, well, we're dividing by 2, right? Which is 100% right. Like those, you're not wrong. But in the equation that we're about to learn about, a times b to the x, that's our exponential function equation, we are going to be multiplying right here. So it's really hard to have an equation that's built around multiplication and then find that we have a division operation being applied to the table. So what we talked about is, well, if we're dividing by 2, what number could we multiply by then to get the same result? Right? So think about 8 divided by 2 is 4, right? Well, 8 times what number could also give me 4? Right? And that number is 1/2. Right? 8 times 1/2 is also 4. So anytime we see that our what we're going to call as like a growth factor or a decay factor is division, we just need to get the reciprocal of it and then turn it to multiplication. So if it's dividing by 2, we're going to multiply by 1/2. And if we find out that we're dividing by 3, that means what we're really doing is multiplying by 1/3. Or if you are dividing by 4, right, you're multiplying by 1/4 and so on. So it just becomes the reciprocal because we need it to be in a multiplication form for the equation. And here is that equation. This is a good spot in the video. You can screenshot this, do whatever it is you need, or write this down in your notes. But this is the bread and butter, right? This is the y equals mx plus b. This equation right here. That was, if you remember, the linear function. That was the equation for a linear function or a line. This guy is its equivalent, right? The y equals a times b to the x is the equivalent to the y equals mx plus b. It's super familiar. It's super common. You guys are going to become very familiar with it and know it really well. And this is what everything stands for. So the A stands for the initial amount. That'd be like in our example of the bank. We started with $1,000, right? We started with $1,000. We put that into a bank, and that's our A value. So wherever you're starting, or known as the y-intercept, right? Where is this thing going to cross the y-axis? And the next point is going to be the B, right? The B is the growth or decay factor. So it's going to be a growth factor if it's above 1, and it's going to be a decay factor if it is less than 1, right? So 1 and above, I guess I could go greater than or equal to 1. It's going to be growth. And if it's going to be less than 1, it's going to be a decay. So that's kind of the idea. So in this case, the decay factor in our problem was 5%. So ours would actually look like this. It's a little bit more advanced than what we need right now, but $1,000 to start. And the 5%, you actually turn it into a decimal. If you remember taking percents to a decimal, you move it 2 spots to the right. So 1, 2, so you have 0.05. That's how we get our 5%. And then the x is going to be our some sort of time. So I would make a note of that. It's going to be generally some sort of time, meaning are we going to get 5% interest every month, every day, every year, every second? What is the time frame of that? And that's the quick kind of synopsis of what everything stands for in that equation that we're going to be using. So let's look at how we write it. This is the goal from the lesson is how do we write that into an equation? So we'll go back a little bit in time from first semester when we used tables to write linear functions, where we had to locate the slope and the y-intercept. So slope came from us finding the change in y over the change in x. So our change in y in this case, I'm going to go kind of quick through it, is change in y, which in this case is 3, we can see here. Also, which is our rise over run, right? So change in y, change in x is 3 over 1. So our slope becomes 3. So y equals 3x plus b. Now this is the main piece, is that our b was our y-intercept, right? So this was our y-intercept. And the way we found our y-intercept was locating wherever x was 0. So wherever x is 0, that is our y-intercept. So in this case, it's going to be 3x plus 2. Right, now that piece of information is the biggest piece that we're going to steal and apply over here, because if you remember, the equation is y equals a times b to the x. in which our A is our y-intercept, right? We can look back up here. It's our initial amount or it's our y-intercept. So we go down here, how do we find the y-intercept? Well, we just did that, right? We just found that the y-intercept over here was where x was 0. So it's going to be the same on this side. Our y-intercept is going to be where x is 0, which is right here. So y is going to equal 2 times whatever b is going to be to the x power, the power of x. So now what we got to do is find the b, our b value, which we look back up here. The b value was our growth or decay factor, right? So this our decay factor here was multiplying by 1/2. We noticed that our y value was being multiplied by 1/2 each time. And up here, our growth factor was multiplying times 2 each time. Our growth factor here was multiplying by 3. So let's look at this guy. What is our growth factor? Right, really difficult when you're looking at fractions. So I'd say skip those for now, and let's look at whole numbers. 2 times 3 gives me 6. So my growth factor is 3. I like to say double check it. Give the next one a shot. Is that one also 3? Well, yeah, 6 times 3 is 18, so our growth factor is 3. And that becomes our equation. We identify the y-intercept, and we identify the growth factor. Okay, let's do a couple more. This one right here, we're going to have y equals, okay, our y-intercept is 27, where the x is 0. And then what's our growth factor? Well, we're multiplying by 3 here, by 3 here, that's 2, it's consistent. Let's put that down to the x, and we're done. All right, this one right here. I would say pause the video right now and give that one a shot. See what you get. All right, now if we look at this, let's go here. Y equals, first thing we want to do is we want to identify where is the x 0. The x is 0 at 10, right? So where x is 0, y is 10. So our y-intercept is going to be 10. The b value, our growth factor, you can see we're dividing by 2. And the same thing that is dividing by 2 is multiplying by 1/2. So we're going to go 10 times 1/2 to the x. And that would be our equation right there. All right, last piece. Now, this piece we didn't cover in the class, but we're going to hit it up today to make sure we all see it. But this is the table. Here is our equation. We're putting all 3 of these together, right? They all go hand in hand. You have a table that can give you a graph. A graph can give you a table. The table can give you an equation, and so on. So we're going to use our equation to fill in our table, and then we'll use that to fill in our graph. So the first thing we can identify is anytime they give you the x of being 0 right here, we know this is our y-intercept, and we know how to calculate that, so we know this guy's going to be 3 right there. And there's a couple different ways we can do the rest of this. I like to just plug these into the equation, if it's me. I like to go here. Well, I know y equals 3 times 2 to the x. Now, this x value, they gave you a bunch of x values. They gave you 5 of them. So let's plug this guy in. Let's plug in a 1 right there. And what do we get? We got 3 times 2 to the exponent 1. And according to PEMDAS, we got to do that first. So that really just gives us 3 times 2, which gives us 6. Now, if this is consistent, we can tell right now that we multiplied that by 2. So we could just assume that this is more than likely going to be times 2, which will give us 12. But we can check it, right? 3 times 2 to the, let's plug 2 in now for our exponent. In fact, let's just go back a little bit. Let's just change color. Let's plug in 2 now. And that's going to give us 3 times 4, right? 2 to the 2 squared is 4, which is going to give us 12, which is what we have down here. All right, so we have 12. And we can work our way backwards by doing the inverse operation. The shortcut is, well, we're multiplying by 2 to work our way down, so we could divide by 2. I'd like to show you what this looks like with a negative exponent because I think it's important to know, but we got 3 times 2, let's go blue here, to the negative first exponent, to the exponent of negative 1. And what that's going to do is that's going to create for us 3 times 1/2 to the first power, right? Because if it's a negative exponent, we have to flip it and do the inverse operation. So now what we have is 3 times 1/2, which gives us 3/2. So we're going to get 3/2 when we multiply it to the negative exponent. You can also plug that straight into your calculator. This equation right here can go straight into your calculator, and it'll give you 3/2, right? So you have 3/2 or 1.5. And if we did the same thing with the -2, we're going to go 3 to the -2. That's really going to give us 3 times 1/2 squared, right? And 1/2 times 1/2 gives me 1/4. So we have 3 times 1/4, which simplifies into 3/4. So we're going to get 3/4 right here. So now we just took everything from the function, the equation, and put it into a graph. And from the graph to from the table to the graph, we just follow and plot our points. So let's just start at the middle. We'll start with 0, 3. So 0, 3, that's our y-intercept right there. And then 1 up to the 6. We got the 2 up to the 12 way up top. And then our -1 is at 1.5. So it's about right there. A -2 right there. And then we connect all these together best we can with what we've got. And that's going to continue on forever. And as you can see here, I haven't mentioned it yet, but that is an asymptote, right? And we've talked about that in class. This orange line is going to get super close to this x-axis, but it's never going to actually touch it, right? Which is really important when we start talking domain and range, because you're going to continue dividing these numbers by 2, right, to move yourself left. And if you think about a cookie, right, a cookie is something we can relate to, but you can divide a cookie in half. Then you got a half cookie. Then you can divide that in half, you get a 1/4. You divide that in half, you get an 1/8. You divide that in half, you get a 16th, and then a 32nd. And you can keep going. And mathematically, you can do that forever, right? You're going to have like a microscopic half of a cookie, but you can technically keep cutting those in half and in half. And you're going to get incredibly, incredibly small numbers, but it will never technically ever hit 0, right? Those lines will never touch. So when we look at domain and range, domain is our x values, range are the y values. So the domain is quite simple, right? Domain, which is your left and right, that's your left and right value. Those are all of our domain. And you can have all real numbers, so we can just go all real numbers right there. Any number you can think of, if it's just negative, positive, it'll hit them all. Range, though, is different, right? Range is the vertical. This is going to be our range. And you can see that we're going to go up forever, right? But we're never going to hit this line, right? We're never going to hit 0. So y has to be greater than 0. And as long as it is greater than 0, it'll satisfy this equation. And we'll get more into that, but that's the quick version of how you determine domain and range for this particular graph. So if questions, come see me, shoot me an email. That's a lot right there. High emphasis, though, on getting a table into the equation. That was our main goal. This is all just really good extra stuff that we're going to be getting to in the future. But questions, email, come see me. And thank you.